All right, welcome everyone. So in this video, we will continue working with our algorithm for finding the inverse of a matrix. We did some 2x2 examples. Let's see what happens when we jump up to a 3x3 example. So the first question is asking us to find the inverse of a 3x3 matrix where the top row is 1, 0, 3, the second row is 0, -2, -2, and the third row is 1, -3, 1. So our algorithm will start by setting up the augmented matrix where we put this matrix 1, 0, 3, 0, -2, -2, 1, -3, 1 on the left, and then we put the 3x3 identity matrix augmented on the right. So we first apply a replacement. We're going to place row 3 with row 3 minus row 1. So that's going to give us zeros beneath the first pivot. So we haven't changed row 1 or row 2, but now row 3 is going to become 0, -3, -2, and we have a -1, 0, 1 on the last row. And then the next operation we can do would be to scale row 2 so that we have a pivot of 1 in the next pivot position. So if we scale row 2 by -1/2, we now have 0, 1, 1, 0, -1/2, 0 for row 2 in the augmented matrix, and row 3 has not changed from the previous step. And now let's eliminate below that next pivot. And so for that operation, we could replace row 3 with row 3 plus 3 times row 2. So row 1 and row 2 are the same. We haven't changed them. And after doing this operation, we now have a 0 beneath the next pivot. The next entry is 1, and then the augmented side, we have a -1, -3, halves, and 1. And now we've got to eliminate the entries above that last pivot. So we can first do a replacement on row 1, replace it with row 1 -3, row 3 to get rid of that entry. Rows 2 and rows 3 would be unchanged. And after doing this operation, the top row is 1, 0, 0, 4, 9 halves, and then we have a -3. And again, row 2, we haven't done anything to in this step, and row 3, we haven't done anything to in this step. And now we've got one last operation. Namely, we can replace row 2 with row 2 minus row 3, and that will eliminate this last entry. So row 1 and row 3, we have not made any changes to at this stage, so I'll write them in first. And now row 2 would be 0, 1, 0. And then on the other side, we have 1, and then another 1 after we do the arithmetic. And then the last entry is -1. And now we've got the identity matrix on the left, so the stuff on the right, that must be my inverse. So in this case, the inverse matrix would be a 3x3 matrix. The top row is 4, 9 halves, -3. The second row is 1, 1, -1. And the third row is -1, -3 halves, 1. And that is essentially going through this process of saying, here was matrix A. What were all of the elementary row operations matrix A is doing? Then let's do the inverse of those operations in the reverse order, and out comes matrix A inverse that we found over here. And I would, as always, encourage you to check your work. Check that A inverse equals I3 in this case, and A inverse A also, when we take that product, gives us the identity, the 3x3 identity matrix. Okay. So let's take a look at one last example. Question 2 here has a 3x3 matrix. The top row is 2, 0, 1. Second row, 0, 1, 3. And the third row is -4, 0, -2. So let's go through this algorithm of setting up the augmented matrix and applying elementary row operations to try and make the matrix we started with, write it in its reduced row echelon form. So in this case, in our augmented matrix that we're starting with would be 2, 0, 1, 0, 1, 3, -4, 0, -2. is the matrix on the left, and then we add the 3 by 3 identity matrix on the right. And let me eliminate the -4 beneath this first pivot by multiplying row 1 by 2 and adding it to row 3. So we're going to do a replacement on row 3. Rows 1 and row 2 are the same. We get a 0 here, we get a 0 here, we get a 2 times 1 plus -2, which also gives us a 0 here, and then we get a 2, a 0, and a 1. So notice at this point, this bottom row, there's going to be no pivot in this bottom row. So at most, we can see we have 2 pivots when matrix A is put in reduced row echelon form. So since matrix A, I'm calling this matrix that we started with A, is not row equivalent to the identity matrix, this tells us that A does not have an inverse. So this matrix A is not invertible.